This is an example on combustion reaction. The question is saying that ethane is burned with 50% excess air. The percentage conversion of ethane is 90%. Of the ethane burned, 25% reacts to form CO and the balance react to form CO2. Calculate the molar composition of the stack gas on the dry basis and the mole ratio of water to the dry stack. So here you can see that ethane is partially combusted to form CO. So we'll have two equations here. So our first equation is C2H6, our ethane, plus oxygen, O2, will produce CO plus water vapor, H2O. This is our first equation. And then we have our second equation where ethane will react with oxygen to produce CO2 plus water vapor, H2O. So this is our second reaction. So first of all, balance the equation. So we have 2 carbon here, so I can put 2 here. I have 6 hydrogen, so I can put 3 here. Now I have 2 oxygen, and here I have 2 plus 3 is 5. So I can put here 5 over 2. The same thing for reaction 2. 2 carbon and 6 hydrogen. Now I have 4 plus 3, so 7. So I can put here 7 over 2. So this is my equation, balance. Next thing is that I can choose a basis since no value is given in our question. So for this question, I can say that my basis is 100 mole of ethane. The next step is that we just draw our flowchart and label all the knowns and unknown variables. So let's say this is your reaction system. We have one flow coming in, which is our 100 mole of ethane. And then the second stream is our air, which we know is 50% excess air, right? And we can say that the composition of air coming in, we can say is 0.21 oxygen and 0.79 nitrogen. And then on our product side, we'll have the unreacted ethane here, unreacted oxygen. We'll have our product, which is CO, CO2, H2O, and also the inert nitrogen gas. So I can label here, this one is my N1, oxygen is N2, CO is N3, CO2 is N4, H2O is N5, and our inert nitrogen is N6. And I can also label here, since I don't know what is my speed of air, I can say that speed of air is N7. So this is our completely labeled flowchart. Now the first thing we can do that we can solve for excess air. Now we know the formula for excess air. Percentage of excess is equal to mole of air fed to the system minus mole of theoretical air needed divided with the mole of theoretical air needed times 100. Now when we are dealing with theoretical air needed, we only consider the complete combustion reaction. So in this case, I have that from the equation 2, 1 mole of ethane will react with 3.5 mole of oxygen. 3.5 is 7.2. So we are only considering this reaction. If I have 100 mole of ethane, I will have 3.5 times 100. So I'll get 350 mole of oxygen. And we also know that in order for us to find the theoretical mole flow rate of theoretical air, we can say that m theoretical is equal to 350 mole of O2. So we know that for every 1 mole of air will have 0.21 mole of O2 based on our composition here. So we can get the mole of theoretical oxygen air that we have is 1666.7 mole. So since we know this, so we can find the value of mole fat by substituting into the equation. So 50% is equal to mole fat minus 1666.7 divided with 1666.7 times 100. So I can get my N7, which is my mole of air fed to the system, is equal to 2500 mole. Okay, so that is how we solve for N7. So next, we want to solve for N1 until N6. Now you have two options. Either you can do molecular species balance or you can do atomic species balance. And we already discussed in our previous class, we said that it will be easier if we use atomic species balance when we have two or more equations. So since we have two or more equations, we have two equations here. So I'll be using atomic balance to solve our material balance problem. So first of all, we have to identify how many atomic species that we have in our system. So if we look at our equation 1 and equation 2, we have carbon, we have hydrogen, and we have our oxygen. Even though we have nitrogen, but since nitrogen is inert, so the balance for nitrogen will be straightforward. So we have 3 balance that we need to do. So let's start with balance on carbon. Balance on carbon. Okay. So on my input side, I have carbon in my ethane. So I can see here on my input side, I have 2 mole of carbon in every 1 mole of ethane. And I know that I have my mole of ethane is 100. So this is on my left hand side, my input side. And on my output side, I have the same thing, 2 mole of carbon in every 1 mole of ethane, which is 2 times N1, plus I have carbon in my CO. So every 1 mole of CO will have 1 mole of C. So I can put here N3, plus I have here also C in my carbon dioxide. So every 1 mole of carbon dioxide will have 1 mole of carbon. So I can put here N4. So this is my first equation. Now, if you remember, we also have percentage of conversion of ethane is equal to 90%. So if remember, the equation for conversion is equal to mole reacted over mole fat times 100. This is the equation for percentage conversion. So I can also put here the mole of reacted here is also equal to my initial mole, which is 100 of ethane, minus whatever I have left in the system, which is my N1, and then over 100, which is the mole fat, times 100. So I can put here this is 90. So from this, I can straight away get the value of N1 is equal to 10 mole of C2H6. 6. So I already have the value of N1 here. And I also have a second relationship with saying that 25% of ethane will react to form CO, and then the rest, which is 75%, will react to form CO2. So I can say here that I can make a relationship between N3 over N4 is actually equal to 25% over 75%. Right? 75%. So here I can also put that is 1 over 3, and based on this one, if I just do arrangement, I can get N4 is actually equal to 3 and 3. So now with this information I have, I can put all the values here in this question. I will get 200 is equal to 2 times 10, which is we got from here, plus N3 plus 3 and 3. So I can use this equation here. So I can get the value of N3 is equal to 45 mole, and I can get value of N4 is equal to 135 mole. So now I have gotten the value of N1, N3 and N4. Next, I can do the balance on hydrogen. Balance on hydrogen. So on my input side, the hydrogen I have 6 hydrogen atom in 1 mole of ethane molecule. So I can put here 6 times 100 is equal to, so I have on my product side, on my right hand side, I have 6 atom again in the unreacted ethane, which is N1, plus I have my hydrogen in my water vapor. So I have, for every 1 molecule of water, I will have 2 atom of hydrogen, so 2 times N5. So I already know the value of N1, which is 10, so I can have here 600 is equal to 60 plus 2 and 5, and I can get the value of N5 is equal to 270 mole. So I've gotten the value of N5. Now the only thing remaining is that I have to do balance on oxygen. So on my right hand side, I have every molecule of oxygen in the air, I have 2 atoms of oxygen. So I can put here 2 times the feed of air is 2500, but I also know that in this 2500 only 0.21 is my oxygen. So this is on my left hand side, on my input side. On my output side, I have oxygen which is unreacted, so we'll have 2 atoms of oxygen in every molecule of oxygen, so 2 times N2, plus I have 1 atom of oxygen in 1 molecule of CO, so I have N3, plus I have 2 atoms of oxygen in 1 molecule of CO2, so we'll have 2 and 4, plus I have 1 atom of oxygen in 1 molecule of water vapor, so I have N5. So since I already know the value of N3, N4 and N5, I can substitute all the values and I can get the value of N2 is actually equal to 232.5 mole. So now I have gotten the value of N1 until N5 and N7. The only thing left is that we do balance on nitrogen gas. So we can just do balance on nitrogen gas. Since it is inert, So will be input is equal to output. So my N6 is equal to 0.79 times the value of the feet of air, which is 2500, and I'll get a value of N6 is equal to 1975 mole. So we have gotten all the values of N1 until N7. So I'll just write back all the values so that we can solve the actual part of the question. So N1 is equal to 10 mole, N2 is equal to 232.5 mole, N3 is equal to 45 mole, N4 is equal to 135 mole, and N5 is equal to 270 mole, and N6 is equal to 1975 mole. So in the question, it asks us to find the composition in dry basis, meaning that if you are talking about dry basis, we must exclude the mole of water, because in dry basis there should not be any water present. So if you add up everything, N1 plus N2 plus N3, N4 and N6, you'll get a value of total mole is equal to 2397.5 mole. So by using this, you can find the value of Y1 until Y6, which is our molar fraction. So you can do this on your own and you should be able to get Y1 is equal to 0.0417, okay, so this is the composition value. And the next part is that the question is asking us to find the ratio, mole ratio of water per dry stack gas. So it's going to be mole of H2O over mole of dry stack. So which is equal to 270 divided with this value, which is 2397.5, which is equal to 0.113. This is your final answer.